So now we're going to do lesson 6.9, recording partial products. So we are on page 134. It says Noah drew a diagram and wrote expressions to show his thinking as he multiplied two numbers. Here's the thing, guys. Once you get the area model, once you understand it, it becomes really easy to use that. Evan used it yesterday to do, like, I don't remember the number, but it looked something like this. A 3-digit number times a 3-digit number. Once you understand the area model, it can work with bigger and bigger numbers, okay? But we don't always want to draw out a big model. So I'm going to teach you how to multiply using that same thought process, just without drawing the box, okay? So that's what we're going to do. It's called partial products. And just the reason, we've talked about this before, the reason that I teach you all of these different strategies is because your brains work in different ways. Some ways make more sense to others. Some people prefer visual models, and some people want to do the algorithms because they're faster, okay? So it's important to teach you the strategies, then you can decide what works best for you. Okay, so here we go. Here's his diagram. This is the problem he's trying to do. 7 times 124. He puts his 7 over here. He breaks apart 124 right on top. And then, his model now, if you look, is 7 times 100 plus 20 plus 4, right? Okay. Then these in parentheses are the 3 expressions that he uses to solve. So he does 7 times 100 first. Then he does 7 times 20 second. And then he does 7 times 4. And he gets 700, 140, and 28. And added together is 868. You good? Oh. If you need to go look, go that way. Okay. How does each expression represent Noah's diagram? So I showed you, I pointed that out. Now, did you see the color coding? The colors are important on this page because now this is the way most of you have seen multiplication problems written before. Ava, stay focused. She just had something in her eye. Okay, so what 2 numbers did he multiply together for this box? 7
times 4.
So look right here. What's in green? 7 times 4. What's the answer to that? 28. Not 8, 28. Okay. On the next one, he multiplied 7 times 20, right? What is 7 times 20? 7 times 2 is 14, but this 2 is in the tens place, so that would be 140. Okay, and then he did 7 times 100. 7 times 100 is 700. So that's another way to do it. It says make sense of each step of the calculation and record your thoughts. We're not going to record our thoughts, but because I just showed you how each one applies to the area model. Okay. Complete the diagram to find the value of 217 times 8. Okay. Here we go. So this is what we did yesterday. They have taken the 8 and put it right here, and they put 217 in expanded form right there. So you guys tell me what we multiplied together first.
8 times 200.
Yep, so write that in the box. 8 times 200.
8
What?
times
Just a second. What do we multiply for this box?
8 times 10.
Okay. And for the last box?
8 times 7.
Okay. Here we go. So, look over here what they've got. 8 times 7. 8 times 10. 8 times 200. See the same expression. What is 8 times 200?
8 times 200.
1,600. What's 8 times 10? 80. What's 8 times 7? Right? Gerald, I'm right, and so you write 2. Okay. Now, we're going to put a 56 right here. We're going to put an 80 underneath it. And then we're going to put 1,600 over here. And the last step is just to add those 3 answers together. Oh wait, I messed that up. 8 plus 5 is 13. There we go. Okay. So, do you see how the area model is related? All you're doing is, instead of drawing the area model, you're using just this. And you're saying, first I'm going to multiply these two numbers together and get 56. Then I'm going to multiply this times this. And because it's in the tens place, this is actually a 10, right? And get 80. Then I'm going to multiply this times this and get 16. But since it's in the hundreds place, I've got 2 zeros. And then add them together, just like we stack them and add them over here. Okay? The spring is wreaking havoc on my allergies. Okay. Try an algorithm with partial products. Look at these two problems. Tell me what, so we've got 3,419 times 8, Noah's method. 3,419 times 8, Mai's method. What's the difference? Mary, do you see it?
The bigger number is on the bottom of Noah's and the bigger number is on the top of Mai's.
Exactly right, but they're the exact same numbers. 24,000, 24,000. 3,200, 3,200. 80, 80. 72, 72. Zerelda, the only thing that they did differently was they multiplied in a different order. So they put the bigger number on top, and then, Maya put the bigger number on top, Noah put it on the bottom. Does it matter?
No.
Is 2 plus 3 is 5. 3 plus 2 is 5. The order of adding does not matter. Okay. So, how are they alike? They are both using partial products but are going in the opposite order. Now, when I'm writing numbers down, I like to start with the bigger number on top. We have to when we subtract, right? But I think it's easier to start with a big number and then get small with the biggest number, biggest place value, biggest number of digits, and then arrange the smaller ones like that. I think it's harder to start with like a 2-digit number, and then you might have a 4-digit number, and then a 3-digit number, like having a weird order. So, I prefer Mai's method, but we're gonna do it both ways so you can see which one you prefer. Use it, so I think there's, hang on just a second, they've got 2 problems left, but number 2 says use a diagram to show what each of the partial products represent, then find the value. We're not going to do number 2, we're going to skip to the last page. Okay, and we're going to, over here, we're going to do 5,342 times 4, and this one we're going to do Mai's method, which starts with the bigger number first, and then over here we're going to do Noah's method for this problem, 983 times 7. First thing on partial products that I suggest that you do, 5,342 times 4. Very first thing that I suggest that you do on these problems is put little tiny zeros to remind you to use them. So this isn't really a 5, it's a 5,000. This isn't really a 3, it's a 300, and that's really a 40. You need to get busy copying. Okay, here we go. We're going to do Mai's method first, which means we're going to start by multiplying 4 times 5,000. 4 times 5,000. Then we're going to multiply 4 times 300. Then we're going to multiply 4 times 40. And then we're going to multiply 4 times 2. So 4 times 5 is our basic fact, is 20 with 3 zeros behind it. So 20 with 3 zeros behind it. Then we have 4 times 3, which is 12 with 2 zeros behind it. So how many digits is that all together? 12 with 2 zeros. Shout it out. 4. 4 digits. So that means I'm going to go 1, 2, 0, 0. Line up your commas. Then I'm going to do 4 times 4, which is 16 with 1 0. Then I'm going to do 4 times 2, which is 8. And last, I'm going to add them all up. 21,368. And then we're going to do the last problem, which is 983 times 7. Now, like I said a minute ago, the very first thing that I do before I start partial products is add little tiny zeros. So 1 here and 2 here. That's supposed to be a 0. It's not really working. Okay, we're going to start with 7 times 3. Nope, we're not multiplying yet. Then we're going to do 7 times 80. And then last, we're going to do 7 times 900. Okay, so first answer we have is 21, and then 560, and then 6,300. So when we add all those together, we will get, is that right? Yep. I think so.
So, yeah, that's correct.
Okay. All right, 6,881. Which do you like better? Do you like to do bigger numbers on first and then?
Yes.
That's how I prefer. I think it's easier than trying to figure out, okay, so I had a 2-digit number. This one's going to be a 4-digit number. So I'm going to have to move it around. Okay.